Alrighty, welcome to Module 6, Lesson 10, Conditions for a Unique Triangle, Two Angles, and a Given Side. Okay, and as you can probably guess, similar to Lesson 10, where we had two sides and a given angle, two angles and a given side are also going to prove to be conditions that will create a unique triangle, okay, and of course would create identical triangles using the two angle and a given side measurement. All right, so we are going to move into this. I just wanted to show you something that will help you through this lesson, and you may have something else other than this at your house to help you out. You're going to be doing some flipping of some geometric shapes. So let me show you something here. Okay, so these little sheets here, these are called patty papers, and that's P-A-T-T, patty, and that stands for hamburger patty. And these are little papers that go between hamburger patties. You can buy them in boxes. Here you can see a little stack of them. They are about 4 or 5 inches square. Okay, you could use those patty papers for this lesson, or you could also use something called parchment paper. Your mom or dad may have some of that in the kitchen. Okay, often used to line cookie sheets when you're making cookies or other baked goods. Okay, so if you have some parchment paper or patty papers at your disposal, it would help quite a bit for this lesson. Okay, so if you remember back in Lesson 8, we explored drawing triangles under the conditions that two angles and a side length were provided, but the arrangement of these parts was not specified. Okay, if you remember, we didn't say, which angle was well, I guess we did with the angle. The side, remember the side differed, and we made those 3 different triangles, 3 different sizes, with those same measurements. They go 60 degrees, 30 degrees, and then 10 centimeters. We ended up with 3 non-identical triangles that we drew. But in this lesson, we explore what happens when this condition is modified, okay, to take arrangement into consideration, okay, to pay attention to where those different measurements are. So instead of drawing triangles given 2 angle measurements and a side length, we will draw triangles under the condition that 2 angles and the included side is provided, and under the condition that the 2 angles and the side opposite a given angle is provided. Okay, so we're going to do 2 different things. One is going to have 2 angles with the included side, and then 2 angles and a given angle. Okay? Alright, so let's get going. Here's our exploratory challenge. Alright, exploratory challenge, a triangle XYZ has angle measures where angle X equals 30 degrees, angle Y equals 50 degrees, and included side XY is 6 centimeters long. Okay, so go ahead and draw triangle X prime, Y prime, Z prime under the same conditions as XYZ. Leave all construction marks as evidence of your work, and label all side and angle measurements. Okay? And under what conditions, answer these later after you're done with that, of course, as usual. Under what condition is X prime, Y prime, Z prime drawn? Compare the triangle you drew. Again, here we go. This is the same thing we've been seeing and hearing over and over again. Of course, we don't have peers to compare our triangles to, but whatever. All right, so just go ahead and do that, put that together, and come on back and see what I produce. Okay, well, here we go. Here's what it looks like out of my answer guide, which is what I think I will do the rest of this lesson to save me a little time so we can get through all of these this school year. So here we go. So we have angle x, okay, so we're meeting all these conditions equal to 30 degrees. We have y at 50 degrees, and then we have the included side, which is xy, is 6 centimeters long, okay? So now we've drawn x prime, y prime, z prime, okay, and there we go. We went ahead then and measured all these different sides, and we see that 4.7 centimeters here, 3.1 centimeters here. Your numbers are probably going to be very, very similar. This, of course, is 100 degrees because we have 30 and 50 already, so it needs to be 180 total. And then we've marked our point up here, that vertex Z right there, where those lines intersect. Okay? So there you go. Again, if we compared our triangles to others in the class, we would have found out that they would have been similar, because this is indeed a condition that would produce unique triangles. All right. So yeah. So the condition here, we have the two angles given and the included side condition. All right. So with that condition, we create unique triangles, which no matter who does it, who creates them, they should be identical. Okay, so we have number 2 here in our exploratory challenge. Another triangle, RST, has the measures that angle S is 90 degrees, angle T is 45 degrees, and we have an included side of 7 centimeters, which is ST. Okay, and again, just as we did before, you're going to draw triangle R prime, S prime, T prime under the same condition. All right, and you can see same condition again is the same, two angles given and an included side. Leave all your construction marks as evidence of your work. Okay, and this is pretty much the same exact problem. So go ahead and, well, not the same problem, but same conditions and everything. So go ahead and do that, and come on back and check in on the one I copy. Okay, so here's what yours probably would have looked like. It could be facing a different way. It wouldn't matter, as long as you have everything in its right place. You can see the conditions. Well, the condition, of course, that we drew this under were when we had two angles given, which were here, angle S, which was 90 degrees, and then we had angle T at 45 degrees, and then we had the included side ST, which was 7 centimeters. Okay, if we do that, we will, each and every one of us, come up with a triangle that looks exactly like this one. Okay, and again, you can see you have of course, you have a 45 degree angle there, of course, as they all need to equal up to 180. Okay, and then we have 9.9 centimeters on this side and 7 centimeters on this side. So actually, if we want to do this, further ticks, we could put a tick mark here and a tick mark there to show that those two sides are equal. And this is actually an isosceles triangle, which we talked about before, where two sides are the same. It is also, of course, a right triangle, because we have our 90-degree angle right there. Okay? Alrighty, so that's what that looks like, and yes, indeed, there is no other way to draw this triangle. Okay, so here's number 3. We've been successful 2 times in a row in creating unique triangles and creating conditions that will create identical triangles. Alright, so here we go. Number 3, you have a triangle JKL. It has measures where we have angle J at 60 degrees, angle L at 25, and then we have an included side at 5 centimeters. Alright, so now you're going to go ahead and you're going to draw angle JKL under the same condition, or sorry, J prime, K prime, L prime under the same condition. Leave all construction marks as evidence. Under what condition? Okay, same instructions. All right, so go ahead and do that, and come on back. Okay, so right away you might have noticed something different here when they've given you these conditions here. If you notice, they gave you angle J and they gave you angle L. Now the difference, okay, and they gave you side KL. Okay, so we just drew just a random triangle right now. You always follow the letters. So if we had JKL, for example, we'd have boom, 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 like that. Okay, and what you notice is you're going to get J, and you're also going to get L here. Okay, which might be a little bit difficult, just because you're not actually. Then you're getting this side right here. Okay, so what's difficult about this? What we usually had before is we had two angles, and then we had this in between side given. Okay, a little bit different. A little bit easier to do. Okay, so you're not actually given like this adjacent, this and this one here, for example, to work with. So let's just go ahead and look. I hope that didn't confuse you. But anyway, this is sorry about all the noises. What you had to do here is I want to just show you how to use the patty paper now. Okay, to solve one such as this. Okay, because it might be a little bit difficult, so using the patty paper can help quite a bit, right? That patty paper or parchment paper. So first, what I did, I went ahead and drew a 25-degree angle on a piece of paper, a piece of white paper, or you could just do it right there on your right there in your binder. Okay, I do the 25-degree angle. The next thing I did is I took a piece of the patty paper or parchment paper, and I drew a 60-degree angle. Okay, so I'm giving myself this other angle, and just show you what I'm going to do here. So what I have is I have that piece of parchment or patty paper overlaid on to the 25-degree angle I created, and you can see how they're not quite centered yet. And again, making sure that you have this here, the 5-centimeter line accounted for as well, which makes a huge difference. Okay, so then what I do is just go ahead and slide that down. Okay, and when I slide it down, I had to tilt it back this way, as you can see. So this right here, this angle right here, is not a perfect 90-degree angle, which of course it's not going to be, because 60 and 25 equals 85. So well, we kind of know what it's going to be already, don't we? But anyway, it's a nice way to actually be able to line it up. Okay, and when I line it up, after I line it up, I can go ahead and use my protractor. And what I did is I just put my straight edge against this line here and made this dotted line here. Okay, and then after I put it on, I could laid the protractor down again, and you can see right there where it lands about 95 degrees. It should be perfectly 95 degrees, but things are seldom perfect. Okay, so you can see how the patty paper can help you with that, because you have more or less a kind of a floating angle here, because if we just go back and just look at if you look at this picture right there, okay, you can see that what you have is we have a side and one angle that's adjacent to the side, and there is one angle opposite to the side. Okay, the side and the adjacent angle, okay, this 25-degree one right here, this initial one that we drew, okay, those are easy to do. Okay, we've got our side, we can measure that out, and then we can draw that 25-degree angle. Okay, positioning this angle here, okay, is a little bit more difficult. Okay, So you have this kind of floating angle, and then you could just move it around until you actually, line up this line with that line, okay, in the proper positioning. So, yeah. So this patty paper, parchment paper, can help you a great deal. Okay. Okay, so to sum up this triangle, the condition on this triangle JKL, or actually J prime, K prime, L prime, is the two angles and the side opposite a given angle condition. So you have two angles that were given, okay, and those were the J and the L, okay, and then you also had a side opposite the given angle condition. Okay, so you had this side here given, okay, and it was opposite of J, of angle J, okay, over there, and so that was it. You had that was the condition. Okay, all different kinds of conditions we've been talking about. That one is two angles and a side opposite one of the given angles. Okay. So you saw what I did to actually get there with the patty paper. There is no other way to draw this triangle, okay? So therefore, the condition determines a unique triangle. What I mean by that, of course, is if several of your peers drew an angle with these conditions, this is the angle they would draw. Okay. All right. Let's move on to the next. Alright, so a triangle ABC has the measures C equals 35 degrees, B equals 105 degrees, and included side AC equals 7 centimeters. Okay, so now I want you to go ahead and draw, of course, A prime, B prime, C prime under these same conditions. Okay, again, leave all your construction marks. This is the same. Just want to ask you again, what conditions were they under what conditions were they drawn? And then, of course, you can't compare it to any of your peers, but it might be fun to have your mom or someone else who's working with you do this as well. Or you can just look at mine, see if they look the same. Okay? And then, again, the question, did the condition determine a unique triangle? And yada, yada, yada. Okay? So go ahead and give that a whirl. I'm going to go ahead and use some patty paper again, and hopefully you have some parchment or some sort of see-through tracing paper at home you could use as well. Okay, well, I hope you are using some sort of see-through paper, parchment, tracing, or patty paper, because boy, it does work wonders, huh? You got to work with it though. So let's go ahead and take a look at my process here. So again, I drew my my first angle, and this is very easy. This is the easiest angle to draw, simply because you have the given side already. You have your given side, and then you have your given angle, and it's easy enough to create that. Okay, so next, oops, let me get rid of that. I have my patty paper, okay, and I drew my 105-degree angle on that. All right, and then went ahead and slipped it over. Okay, and again, it started out real high. You can see how my first angle extends below here. Okay, and my patty, you can see how this was a little bit, see how long it was. So I had to really drop that thing down to actually fit it to fit perfectly, and it is pretty perfect because when I went ahead and used my protractor, I know it has to be 40 degrees, but there it is, my 40-degree angle right there. Okay, so it's nice, this process, to be able to draw the triangle so accurately, because again, this the angle up here is going to be it's a floating angle, and you don't know this angle here yet, so it's very difficult to actually draw, and because you don't know these side lengths. Okay, you just don't know where you're going to draw that angle, okay, because you only knew this one. All right, so those conditions, of course, were I had two angles again, and the side opposite a given angle condition, which is the same as we had last time. All right, all the triangles will be identical, okay, and this condition determined a unique triangle. Okay? And yeah, that was my process. Hopefully you are finding utility in this process as well. Okay, well, we'll go ahead and sum up this lesson now here with this very, as you can see, very brief summary right here. But before I do, just right here, just today we saw two conditions that determine unique triangles. Okay, we had well, I mean, what is the first of all? Let's look at the complete list of conditions that determine unique triangles. Okay, so we have three sides. Okay, if we have all three sides, we know that these triangles will be identical. Okay, we have two sides, or we have two sides and an included angle. Okay, remember that. These are from lessons past. Two sides and included angle. Right. And again, if you want to write all these down, that'd be super. So that's one condition, two conditions. All right. And then the third one is one that we used in this lesson here, and that's the two angles and the included side, okay, which is right here. And then we had two angles and the side opposite a given angle, okay, condition. So these are, all four of these are different conditions that if they are indeed given, if all these conditions are given, these will all produce unique triangles, okay, which means unique in the sense that, it's funny, unique is an interesting word because it would seem that it would mean that every angle would be different, but every triangle would be different, but the truth is every triangle would be the same. So maybe I should say identical unique triangles, okay? It's going to be, because if I give you three sides, okay, that, if I give you three sides, let's say they're all 5 centimeters, okay? All three angles are going to be the same, same as well in that case, but they'll always be the same. It'll be unique. That is a unique triangle, okay? All right, I'm not sure if that's clear, but anyway, I hope you enjoyed this lesson and have much success on your problem sets, and see you in lesson 11.